Time for the Unit 2 Lesson 8 homework. Obviously, it's with me, Miss Billman. I love this section. Why? Because it is polygons. And polygons are really fun because we get to see some unusual shapes. So when we're looking at the perimeter, like of this polygon, I know that the side lengths are all the same. They're 8. And I could go around and count them 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 sides. And I'm going to multiply that by 8 because the length is 8. And I get 64 feet as my perimeter. But now when I'm finding the area, the cool part is I've already learned about triangles, right? We did those. So I'm an expert at a triangle. All of these shapes are made up of triangles, just depending on how many. And I pull one triangle out. It has a base of 8 and a height of 10, or a distance to center of 10, which is the height. I multiply those. 8 multiplied by 10 is equal to 80 divided by 2 is 40. So that's telling me every single triangle is 40 feet squared in area. Now, how can I find the area of the total? Well, I have 8 triangles. I can multiply that 40 by 8 and get 320 feet squared as my area. I'm taking something that has many sides and I'm breaking it down into something I can understand. So I go ahead and label my sides. They're each 4 inches. 1, 2, 3, 4, 5. It's a pentagon. So 4 multiplied by 5, that's how many sides there are. I have a perimeter of 20 inches. I pull out one triangle. I'm decomposing this into many triangles. So by finding the area of one, I can multiply to find the area of the whole thing. So I have my triangle with a base of 4 and a height of 3. 4 multiplied by 3 is 12. 12 divided by 2, because it's half of a quadrilateral, is 6. Each triangle is 6 inches squared. I have 5 triangles total. 6 multiplied by 5 is, drum roll, blah, 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 30. 30 inches squared for my area of that pentagon. Same thing for number 3. I label my sides so I could do the perimeter. 5, and I have 1, 2, 3, 4, 5, 6. 5 multiplied by 6 equals 30 yards. Now I pull out one triangle. I pull it out. It has a base of 5 and a distance to center, or height, of 4. 5 multiplied by 4 is 20. Now if it was a quadrilateral, I could stop there, but it is a triangle, so I must divide it by 2. 20 divided by 2 is 10. So then I could go through and label each part of that. 10 yards, 10 yards squared, really 10, and I would add that up, or knowing that there are 6 pieces in this little puzzle I have, I could multiply 10 multiplied by 6 and I would get an area of 60 yards squared. For numbers 4, 5, and 6, I'm going to be doing the same thing. We're looking at other shapes and finding the area and perimeter. I go ahead and label my sides. There are 9, in this case 9 meters. And I can multiply 1, 2, 3, 4, 5. 9 multiplied by 5 is equal to 45 meters. Now to find my area, I pull out one of the triangles. It has a base of 9 and a distance to center of 6. 9 multiplied by 6 divided by 2. 9 multiplied by 6 is 54. I divide that by 2 and I get 27 meters. Now that is just for one. If I cut this into triangle pieces, that one's kind of a wobbly triangle. I would have 1, 2, 3, 4, 5. 5 triangle pieces. 27 multiplied by 5. 35, carry the 3, 13. So 135 meters squared. Number 5. I'm going to label each side 7, 7, 7, 7, all the way around. And I can multiply 7 by 1, 2, 3, 4, 5, 6. I could also add 7 6 times. I could say 7 plus 7 plus 7, but repeated addition is multiplication. So I have a perimeter of 42 centimeters and I have an area. I pull out a triangle and I have an area where I would multiply 7 by 6, it's 42, divided by 2 is 21. And I have 6 sides, and I would get 6 triangles. So I will multiply 21 by 1, 2, 3, 4, 5, 6. There's 6 and 12, so 126 cm squared. Number 6. Now I'm using the same numbers. It's a different shape, but I'm using the same numbers, but they're flipped. So I have a side length of 6 and a distance to center, or my height, will be 7. So 6 multiplied by 8, because this is an octagon, is 48 km. Now I pull out one of the triangles and I'm going to label it. My base of 6, my distance to center, or my height of 7. 7 multiplied by 6 is 42, divided by 2 is 21. I have 8 pieces of this octagon. I always think of an octopus. It has 8 legs or tentacles. So each piece is 21 km, or I can multiply. 21 multiplied by 8, I get 168 km squared. Number 7 and 8, these are story problems, and we're going to work through these together. So Talia made a pattern for a pot holder that is a regular 12-sided polygon. Oof. The perimeter of the pot holder pattern is 36 inches. The distance to center is 6 inches to the nearest inch. What is the, I'm guessing it says area, my hand's covering it up. So yeah, what is the area of the pot holder to the nearest? So I have lots of things I got to think about. Now, what I could do, I could draw a 12-sided polygon. Sometimes I can do this like, woo, yep, this is easy. 12 sounds like it would kind of hurt my head. But I can divide this. I have my distance around 36, and if I divide it by 12, which is the amount of sides, I can find out the length per side. So 36 divided by 12 is 3. So each side length must be 3 inches long. So that's the base of my triangle. Now I'm back to still having a regular triangle, right? It told me the distance to center is 6 inches. So 6 multiplied by 3 divided by 2. That's 9. So for one triangle of this polygon, it's 9 inches squared. I'm going to multiply it by 12. Why? Because it is a 12-sided polygon. 9 multiplied by 2, 18, carry the 1, 108 inches squared for the area. You can totally draw a 12-sided polygon. I know off the top of my head, that might be a little outside my comfort zone and my time limit for this video. A house number is displayed on a plaque in the shape of a regular 7-sided polygon. The area of the plaque is 70 inches squared. The perpendicular distance from a side to center is 5 inches to the nearest inch. What is the perimeter of the plaque? So now I'm going to have this area that I start with, right? So I know it's 7-sided polygon. I also know my perpendicular distance from the side. That's another way of saying my distance to the center, or the height. The height is 5 inches. Now I'm going to label my base as B, and I'm going to write the formula. B multiplied by 5 divided by 2 is going to give me a square. That square is my answer for the area of one triangle. But I have 7 triangles, so that square multiplied by 7 has to give me 70. So right now I'm using my problem-solving skills to think, what numbers could go in there? Now, I happen to know a number that when you multiply it by 7 gives you 70. It's 10. Now it's just like one of the regular problems we have when we're looking at triangles. If I have an area of 10 inches for a triangle, what is the base? So I would normally say, hey, it must be 2, right? Because 5 multiplied by 2 is 10. But with a triangle, we have to divide it by 2. So it actually must be 4. 5 multiplied by 4 divided by 2, it's 20 divided by 2, which is 10. So now to find the perimeter, I know each base or each side length must be 4 inches. So I could count that up 7 times, 4 plus 4 plus 4, or I could do 4 multiplied by 7 is 28 inches. And so that's how I go from something big and go down right to that variable.